All right, let's talk about the cloud. It's a term we hear, like 100 times a day? Our photos, our shows, our entire work life, it all lives in the cloud. But what is it, really? Okay, let's just dive right in and break it down.
Right? It feels like this invisible, kind of magical place where all our digital stuff just exists. We all use the term, but if somebody asked you to point to it, where would you even point? That's the big question we're going to answer today.
So, the absolute best way to get your head around the cloud is with a really simple analogy. It's not a thing you own any more than you own the local power plant. It's a utility. It's a service you plug into for computing power, just like you plug your phone into an outlet for electricity.
And that's the crucial thing to understand here. The cloud isn't just some new piece of tech. It is a fundamental shift in how we do things. We've gone from buying and owning our own servers, our own little power generators, if you will, to a pay-as-you-go model where we just rent computing power from this massive shared grid.
This quote just nails it, doesn't it? Like, with electricity, you don't need to know how the turbines work or how the grid is maintained. You just flip a switch, you connect to the internet, and bam, the service is there right when you need it.
So, if the cloud is a grid, then where are the power plants? Well, they are very, very real, and they are absolutely massive. The cloud physically exists inside these hyper-optimized, incredibly efficient buildings called data centers, and they're spread all over the world.
And that's all the data center is really. A central building just packed to the gills with the servers, the storage, and the networking gear that makes up the physical engine of the cloud. These are the humming, air-conditioned hearts of our digital lives.
And these places are just masters of efficiency. Seriously, we can measure this with a metric called power usage effectiveness, or PUE, where a perfect score is 1.0. The average for a modern data center, an incredible 1.21. That is insanely good. It means for every watt of power going to the actual computers, only a tiny, tiny fraction is used for stuff like cooling. You just can't get that kind of efficiency trying to do this on your own. But hold on, how do you take all that immense power in a data center and slice it up for millions of different people? Well, that's where the real magic comes in. The key technology is called virtualization. If data centers are the power plants, think of virtualization as the transformer that lets everyone tap into the grid safely and efficiently.
So, virtualization is this super clever layer of software that takes one seriously powerful physical server and carves it up into dozens, maybe even hundreds of smaller, totally independent virtual servers. Each of these virtual servers thinks it's its own separate machine, but really, it's just a small, isolated piece of the real hardware.
And the impact of doing this is just staggering. Before virtualization, a typical server in a company's closet was only using about 15% of its total power. What a waste, right? But with virtualization, that usage number skyrockets to over 60% just by letting one server pretend to be many. This is the secret sauce to the cloud's efficiency.
Okay, so we've got it. The cloud is a utility grid, it's made of data centers, and it runs on virtualization. So how do you actually plug in? Well, you do it through different service models, and each one gives you a different level of control over what you're doing. Let's stick with an analogy. Think of it like building a house. At the bottom, you have infrastructure as a service, or IaaS. This is like the cloud provider just gives you the plot of land and the utility hookups. The raw servers and storage. You have to build the whole house. Next up, platform as a service, PaaS. Here, they've already poured the foundation and put up the framework. You get the operating system, the tools, you just build out the application. And at the very top, you get software as a service, SaaS. This is the fully furnished, move-in ready house. Think Gmail or Salesforce. You don't build a thing, you just walk in and start using it.
So why does any of this technical stuff actually matter? Because this information grid is what's powering, well, pretty much every single piece of our modern digital lives. Let's look at a couple of quick examples.
The ability to watch any movie, anytime, anywhere, that requires a ridiculous amount of storage and bandwidth spread all over the globe. That is the cloud. Without it, there's no Netflix, no Spotify, none of that on-demand entertainment we take for granted.
You want to make sense of these enormous data sets, from weather patterns to stock market trends. That takes unbelievable amounts of computing power, but usually just for a short burst of time. The cloud's whole pay-as-you-go model is what makes this kind of analysis possible for everyone, not just giant corporations.
Training a modern AI model might be one of the most computationally intense things we do on this planet. We're talking thousands of processors running nonstop for weeks. The cloud's elastic on-demand power is the perfect engine for this whole AI revolution.
And what about the billions of smart devices out there? Your watch, your thermostat, your car. They're all sending tiny bits of data every single second. Well, the cloud acts as the central brain, collecting all of that, processing it, and making sense of that constant, massive river of information. So what's next for the grid? It's evolving. To power the next wave of technology, like self-driving cars, the cloud can't be hundreds of miles away in some data center. The power plants, or at least some mini substations, they need to be much, much closer to us. And this is called fog or edge computing. The idea is actually pretty simple. Instead of sending data all the way to a massive data center and back, you process it on smaller servers located at the edge of the network, maybe even on a cell tower right down the street. For things like the Internet of Vehicles, where a single millisecond of delay can make all the difference, this kind of speed is absolutely critical.
So we've kind of gone on a journey here. We've seen the cloud go from this vague idea into a very real, physical grid of information power. It's become the foundation of our world, but now that grid is pushing outwards, right to our doorstep. So the only question left is, what new realities are we going to build on top of it?